Thank you for joining me. Welcome to TJ's Maths Clinic. Still on Senior School Certificate Examination, NECO 2025, General Mathematics Paper 2. With us here is question 6 from the optional parts. This is the first question. The question 6 reads, given that the matrices A, we have matrix A as 3 by 3 matrix. We have the element or the entries as 3, 3, 1, 2, 1, 4, 4, 3, 1, and the matrix B is given as 4, 1, 2, 2, 5, 1, 3, 2, 4. Question A, we are asked to find the determinant of, that's Roman numerals 1, the determinant of A, the determinant of B. Question B, find the inverse of A. Of course, this is from matrices and determinant. Let's look at how we can handle this. First question, we are asked to find the determinant of this matrix, 3 by 3 matrix. Very important. The rule is here, this is the first column, first row. So here will be plus. This is the second column, first row. Of course, here will be negative. This is the third column with first row. Of course, here will be positive. This will be our guide. Let's write down the solution to Roman numerals 1 now under A. That's A, Roman numerals 1. The determinant of A now will be equals to, this is the sign for determinant of A. We'll pick the first element here, which is 3. That will now be 3. We close this first row with the corresponding column here. Then we pick the leftover element, which is 1, 3, 4, 1. So we'll have 1, 3, 4, 1. We do the same. We move to the second column now with this first row. We do the same. We pick, that will be minus 2 now. That will be minus 2. Then we do the same, meaning we close this column, then we close this row. We'll be left with 3, 3, 1, 1. 3, 3, then 1, 1. The last one now, positive 4. So we do the same. This will be plus 4 now. Then we close the column and the row associated with this, meaning we close this and we close this. We'll be left with 3, 1. We're left with 3, 1. Then 1, 4. Then 1, 4. Very important. Then we can now find the determinant of this 2 by 2 matrix now, multiply it by 3. So we'll have 3 now. Leading diagonal minus unleading diagonal. That will be 1 times 1, which is 1, minus, here will be positive and here will be negative. 4 times 3, that is 12. We close. Do the same here. We have minus 2, open bracket, leading diagonal now, minus unleading diagonal will be 3, minus 3. Then plus 4, we do the same. Leading diagonal here, that will be 3 times 4, which is 12, minus 1 times 1. We close the bracket. Very important. We have 3 now. Into 1 minus 12 is minus 11. Minus 2 into 3 minus 3, that will be 0. Plus 4 into 11 minus 1, of course, it will be 11. That is 12 minus 1, rather, it will be 11. Okay? Minus 11 times 3, that will be 33. Minus 2 times 0, of course, will be 0. Then plus 4 times 11, that will be 44. So the determinant of A now will be minus 33 plus 44. That will be 11. So this is the solution to Roman numerals 1. Very important. This is how to go about it. So this is the determinant of A. We are asked to find the determinant of A. Very important. Okay? This is how to go about it. Let me write the determinant here. As I said, the determinant of A now is nothing but 11. So this is said to be the solution to Roman numerals 2. Let's move to Roman numerals 2. We have to find the determinant of this b now. Permit me to clean this so that we can have enough space. The determinant of a is 11. Let's move to Roman numerals 2 now. We do the same approach. Roman numerals 2 now. The determinant of what? The determinant of b. Let's move here and do the same. We have plus here, minus here, and plus here. We pick 4. That will be 4. Then we close this first row with the corresponding column now. We'll be left with 5, 2, 1, 4. 5, 2, 1, 4. We move inside. That will be minus 2 now. Then we do the same. We close this column, we close this row, we left with 1, 2, 2, 4. 1, 2, 1, 2, then we have 2, 4. The last one now will be plus 3. We do the same. We close this row, we close this column, we'll be left with 1, 5, 2, 1. If we close this, we'll be left with 1, 5, 2, 1. 1, 5, then 2, 1. So this will be the method to find the determinant of b. Let me write it here. This is now the determinant of b is equals to this. This is 2 by 2 matrix. Here will be plus, here will be minus. We pick our 4, we open bracket, leading diagonal minus unleading diagonal. This will be 5 times 4. That's 20 minus 2 times 1, 2. Minus 2, we do the same, leading diagonal. That will be 1 times 4 is 4, minus 2 times 2, that's 4. Plus 3, we do the same, leading diagonal, minus unleading diagonal, that will be 1 minus 2 times 5, that's 10. Very important. This will be 4, open bracket, 20 minus 2, of course, will be 18, minus 2 into 4, that will be 0. Then plus 3 into 1 minus 10, of course, will be minus 9. 18 times 4, what do we have? 18 multiplied by 4 will be 72 minus 0 minus 3 times 7 is 20. 3 times 9 is 27. So let's subtract 72 minus 27. What are we going to have? The determinant of b now is 45. Very important. So the determinant of b is nothing but 45. Let me take it up, or let me write it here. The determinant of b is 45. Very important. So we are through with Roman numerals 2. Let's quickly move to b. We are asked to find the inverse of a. Very important. Remember, the determinant of a before is 11. So to find the inverse of a now, let me clean this and leave only a. To find the inverse of A, the inverse of A now, that's a solution to B now. The inverse of A is nothing but 1 divided by the determinant of that matrix A multiplied by the adjoint of A. And to find the adjoint of A, we have to first of all find the cofactor of A before we transpose. The transpose of that cofactor of A will be the adjoint of A. We know the determinant of A already as 11. But since this is under B, we have to find the determinant again of that, the same A. That will be the first step. We have to find the determinant. After the determinant, we find the adjoint before we can now find the inverse of A. So let's quickly find the determinant of A, the same procedure. We pick this is plus, minus, plus. We pick plus, that will be 3. Then we close this, we have 1, 3, 1, 3, 4, 1. We move inside, we pick this first element here, that will be minus 2. Then we close this column, we close this row. We have 3, 3, 1, 1. 3, 3, then 1, 1. The last one now is plus 4. We do the same. We close this row associated with this plus 4. We close this column associated. So we have 3, 1, 1, 4. 3, 1, 1, 4. Very important. So let's find the determinant. It will be 3, bracket open, leading diagonal now. That will be 1 minus unleading diagonal. That will be 12. minus 2 leading diagonal, that will be 3, minus on leading diagonal, that will be 3, plus 4 leading diagonal, that will be 12, minus on leading diagonal, that will be 1. Of course, this will be 3 into minus 11, minus 2 into 0, then 4 into 11. Of course, this will be minus 33 plus 44. And we know that we have 11. The determinant of A is nothing but 11. So we have the determinant of A as 11. So next thing to do is to find the adjoint of A. So let me put it here. The determinant now is 11. We're through with that. Let's clean this side so that we can find the cofactor of A. The A cofactor now, A cofactor, the cofactor of A now will be equals to, very important, to find the cofactor we have to understand this concept. We have plus, minus, plus, minus, plus, minus, then plus, minus, plus. This is the key we are going to use. And the reason why we are having negative here is this is the first column, second row, which is that's 1 plus 2, that's 3. Is odd number, here will be negative. Of course, if we move inside here, this is row 2, column 2. 2 plus 2 is 4. That is even, we have positive here. That's how we come about this sign. Very important. The same thing here. This is row 3, row 3, column 1. If you add 3 plus 1 is 4. That's why we are having positive here. So that's how we come about this. So to find the cofactor, we need this key. So let's start. Very simple. First one, we'll have something like this. Let's see if this will take us. The first one is we close this row, we close this column. We have positive now. We have positive. We'll have 1, 3, 4, 1. That's the first one now. Next, we move inside, which is negative. We have the negative here. We close this, we close it. We have 3, 3, 1, 1. That will be 3, 3, 1, 1. The last one is plus. We close this row, we close this column. 3, 1, 1, 4. 3, 1, 1, 4. That's one. We close this, we close this. We have 3, 1, 1, 4. So this is the first one. We move to this negative now. Let me take it down here. We have negative. We are here now. We close this. We close this. We have 2, 4, 4, 2, 4, 4, 1. 2, 4, 4, 1. We are at positive now. We pick the positive. Yes, we are here now. We close this. We close this. We have 3, 4, 1, 1. 3, 4, 1, 1. The next one now is negative. Then we have something like this. We are here now, which is the last one here now. We close this, we close it. We have 3, 2, 1, 4. 3, 2, then 1, 4. Very important. And let me take the last one here. We have something like this. The last one now will be, we are at this point, which is plus. We close this, we close it. We have 3, 4. We close this, we close this. 2, 4, 1, 3. 2, 4, 1, 3. Next would be negative. We have something like this. Let me remove this. We are at this point now. We close this row, we close this column. Since we are here, sorry, we are at this point. We close this row, we close this column. We have 3, 4, 3, 4. We close this, we close this. 3, 4, then 3, 3, 3, 3. The last one now is plus. Then we have something like this. We are at this point. We close this row. We close this column. We have 3, 1, 3, 2, 3, 1, 3, 2, 3, 1. So this is how to find the cofactor. So the next thing for us to do is to find the determinant. Is to find the determinant of this 2 by 2. Permit me to clean here. And let's find the determinant. The first one now, we multiply this, that will be 1. I have something like this, that will be 1. Minus 12, of course, it will be minus 11. Let me write it direct here. Then we have negative here. We multiply this, that will be 3. Minus 3, of course, it will be 0. Because this is 3 times 1, 3, 3, that's minus, which is 0. So here will be 0. Then we move here, which is plus now. This is 12. 3 times 4 is 12. Minus 1, of course, it will be 11. So I have 11 here. So I'm through with the first one. I will move here now. Do the same. This is 2 minus 16. This is 2. 4 times 2 is 4 times 4 is 16. 2 minus 16 is minus 14. Minus 14 times minus, that will be plus 14. So here will be 14. We move here. This is 3. This is 4. That will be 3 minus 4, of course, is minus 1. So here will be minus 1. Then we have negative here. This is 12. Minus 2, of course, will be 10, but we have negative, that will be minus 10. Okay, so we have something like this. Now the cofactor of what? The cofactor of A. We are here now. This is 6 minus 4, of course, it will be 2. So here will be 2. This is leading diagonal, which is 9 minus 12. Of course, it will be minus 3. We have minus outside here. It becomes 3. The last one is positive. This is 3 minus 6. Of course, it will be minus 3. So here will be minus 3. So this is the cofactor of A. Very important. So the adjoint of this A now will be, let me clean here. The adjoint of A will be the cofactor of A will be equals to the cofactor is given as this. The adjoint of A now, the adjoint of A, let it be B transpose. And this B transpose is the same thing as the transpose of this cofactor now. Let the adjoint of A be B transpose. And let this cofactor be what? Be B. So if you transpose this cofactor or this B, it will be the adjoint. So B transpose now will be, we transpose this, let me write the cofactor like this. To transpose this cofactor now, which is the B transpose now, we change row to columns. So this will now be minus 11, 0, 11. We'll pick this will be 14, minus 1, 10. We have 2, 3, minus 3. So this is said to be the cofactor of this. This is said to be the transpose of this cofactor. The inverse of A now, is given as the determinant of A multiplied by the adjoint of A, and the inverse of A now will be 1 divided by the determinant of A, which is 11, multiplied by the adjoint of A, which is the B transpose now, which is minus 11, 0, 11, 14, minus 1, 10, 2, 3, minus 3. So whatever we have here will be the inverse of A now. So let's multiply or distribute that 1 over 11 now. The inverse of A now will be 1 over 11 times 11 minus 11. Of course, that will be minus 1, because minus 11 divided by 11 will be minus 1. 0, 1 over 11 times 0, of course, will be 0. 1 over 11 multiplied by 11, it will be 1. Then 1 over 11 times 14 will be 14 divided by 11. 1 over 11 times minus 1, of course, will be minus 1 divided by 11. 1 over 11 times 10 will be, we have to be 10 divided by 11. The last one now, 1 over 11 times 2, that will be 2 divided by 11. 1 over 11 times 3, 3 out of 11. 1 over 11 times minus 3 divided by 11. So this is said to be the inverse of matrix A. Minus 1, 0, 1, 14 out of 11, minus 1 out of 11, 10 divided by 11, 2 out of 11, 3 out of 11, minus 3 divided by 11. So this is said to be the inverse of A. Thank you for watching. Please do share this with your learner colleagues, and don't forget to subscribe to TJ's Maths Clinic for more interesting videos. It's a very long question. In my next video, we'll look at question 7 from this optional part. Thank you for watching.